Hi, in this video we're just going to jump straight into Lambda expressions. So let's go ahead and create first a regular function, or at least what we consider a regular function, using the def statement. So we use def, then we have the name for the function, then we specify any parameters if we have any. So in this case, let's say I'm going to do a single parameter. I'm going to name it x, and this function is simply going to return x squared. So this is a function. If we look at the type of SQ, it's a function. If we just go ahead and print out SQ, here's what Python tells us. It is a function, it's in the main module, and it's named SQ. Now we can also define function using a lambda expression. So let's do the same thing. Let's say we have lambda. So that's the keyword, right? Here we use def, now we're using lambda. The difference is that with def, we specify the name of the function and then the parameters in parentheses. For lambda, there is no name for the function, and therefore we specify the parameters without the parentheses. But the same rules that apply to specifying parameters, defaults, the star args, all that stuff works just as well with lambda. The only difference is that there is no name. So let's see what happens. So let's say we take a single parameter, and this will return x squared. Now there's a limitation as well on what you can do in the body of this function when you use a lambda expression. It has to be an expression, because that expression is what will get evaluated and returned, right? So it's like having an implicit return, right? You can't return, a bunch of statements or comments, right? You need to return an expression. So same thing here. You can't put in, comments, you can't put in annotations, you can't have multiple lines of code. So lambdas are meant to be very, very simple functions, essentially, right? Things that can be done this way. All right, so that's the lambda. Let's go ahead and run this, and let's see what Python does. Well, it created this function. And so it created the function in memory at some memory address, and it assigned it. So here we go. All right, so it's a function. Again, same as before. It's in the main module. That's where we're running this notebook. But notice here, it just has this generic lambda name. If we were to do another lambda expression, lambda y, let's say x as well. Well, let's do x comma y. So let's say we do two parameters, right? And we're going to take x plus y. Well, again, you see we get the exact same thing. Function, main, lambda. There is no name. So it just sticks in this word, lambda, to tell us, hey, this is a lambda expression. It's an anonymous function. There is no name, unlike SQ that had a name. So what can we do with lambdas? Well, we can assign them to a variable, right? We can assign a function to a variable. For example, we can say f is equal to SQ. So now if we look at the ID of f and the ID of SQ, we know that they're going to be the same. They're pointing to the same object. That means that f is also a function, so it's callable. So callable means we can call it. We call it using these round parentheses. And so we can pass in 3, and we get 9. That's the same thing as doing SQ of 3. That's 9. Right? So this is how we could assign a function to another variable. Now, the name of the function is still, so if we say f, it is still, the name of the function is still SQ. It's not f. F is just a variable that points to the memory location that contains that function object. So we can do the same thing with anonymous functions, with these lambdas. So we can say f is equal to lambda x and returns x squared. So now we can look at f itself. Well, f is just that lambda expression, right? It is that lambda, it is that function, that anonymous function. And so f is callable, and we can say f of 3, for example. That will return 9. We can do something similar. Let's say we have a lambda, let's say it takes two parameters, x and y. And in this case, I just want to show you, we can set also a default for y. So we'll do that, and then we'll just return x plus y. Okay? So that's what we want to return. So let's go ahead and see what g is. So g is just some function, right? But it's an anonymous function, as we can see here from the word lambda. But we can call it. So we can say g of 1, 2, and that will return the sum 3. Now, of course, since y is optional, we can just specify one positional argument, and y will default to 10, and so we get a sum of 11. Now, of course, you can get more complicated than that if you want. You can make a function, let's say f is equal to lambda, and we're going to take in a positional argument. Then we're going to take in an arbitrary number of additional arguments, positionals. Then maybe we're going to take a keyword only argument. That's going to be mandatory because I'm not specifying a default for it. And then maybe an arbitrary number of keyword only arguments after that. And what are we going to do with that? Well, you could manipulate this in different ways. I'm just going to create a tuple that's going to return basically the values that were passed in, just so we can see that the values were successfully passed in. So I'm going to return x as the first element of the tuple. Then I want to return args, right, which was the extra positionals. But of course, args is a list, so I need to unpack it into the tuple. Actually, I don't have to unpack it. I can leave it that way. Let's do that. And then y, and then we'll take quargs. Okay. So if we do that, we can now call f. Now, if I try and call f just by itself, it's going to tell me, no, you can't. You're missing the argument x. This function here, whatever it is missing one positional argument. Well, yeah, we've got to specify x at the very least. So let's put in a value of x of 1. Maybe some extra arguments while we're at it, but I don't have to, right? They're just optional, but I'll put in a few, maybe a and b. Then we need this keyword. It's mandatory, and it's a keyword only argument, maybe y equals 100. And then we can pass in a few extra ones as well. Maybe a equals 1 and b equals 2, right? Or maybe a equals 10 to differentiate it from the y value. And so there we go, right? We have 1, and we have this tuple that contains a and b. That's what args got unpacked into, or got collected into, I should say. And then quargs was collected into this dictionary over here, and y is 100. Now, of course, if you want, you can unpack things this way, right? You can unpack the args, and if you do that, you just get the list this way. So it depends on how you want to use it. Very often, that's how we want to use it. Now, I can't unpack quargs directly into a tuple, but I could unpack it into a dictionary, which is kind of redundant since it's already a dictionary. So I'm not going to do that, but you can. Okay? And now you just get it this way. So lambdas are functions. They're real functions just like anything else. Or just like any other function, I should say. Okay, so now let's look at how we might pass it now as an argument to another function. Very often, right, we pass functions to other functions. So let's take a look at a very simple example. Let's write a function called applyFunc that's going to take two parameters, x and fn. Fn is going to be the function, and x is going to be a parameter. So fn we're going to call, and we're going to pass it the parameter x. So we expect to receive fn as a function that accepts at least one positional argument. So now that we have that, we can call applyFunc and maybe 3, and now we need to pass it a function that's callable with one argument. Well, we have that already, right? We have this sq, this square function that we wrote up there. So let's go ahead and just use that. So we can call it this way. And of course, here I have to return, not just evaluate. So let's do that again. Okay, and here we've just printed out 9, right? Because it ran sq passing it a value of 3. If I pass a value of 5, I get 25. But what if we didn't have this function sq defined already? Well, we could get to it the same way by using a lambda. So let's say 5 lambda x, which returns x squared. And we get the same result. What happened is that instead of first creating the function up here and then passing it in to the applyFunc call, we just created this function here on the fly. That's a very common use case for lambda expressions. When you want to do a quick function that you're passing to another function, and you don't want to define necessarily a full-fledged function using def, not that lambdas aren't full-fledged, but you don't want to, go ahead and do a def statement to create the function. You just want to create this very quickly. It's useful for those kinds of cases. We'll see some examples of that in the next video when we look at sorting and how we can use lambdas for sorting. Okay, so of course now we can use any other function we want, right? We don't have to use a square. We can define whatever the function we want it to be. Maybe it's a cube, you know, whatever it is. So 5 cubed is 125. Now we can get a little more sophisticated with this, and this is going to tie into the whole thing with the arguments and the keyword arguments that we did in the last section. So let's do this. Let's say we want to apply func, and what I really want to do is I want to pass in an arbitrary number of arguments, an arbitrary number of keyword arguments, so this is very generic, and then I want a function. Now this is incorrect. Do you see why? Right, we can't specify fn after star quarks. That doesn't work. We can't do that. So we're going to have to define the function first. That's going to be a mandatory positional argument that is going to be the function. And what do we want to do? Well, we want to return the function applied to args and quarks, right? Now, of course, I'm calling a function. So I cannot pass it. I'm calling a function that's going to accept an arbitrary number of arguments, an arbitrary number of keyword arguments, right? And this is a list. This is actually a tuple, and this is a dictionary. Well, we don't want that. That's not what we can pass. So we need to unpack args, and we need to unpack quarks, right? So if that's a little confusing, go back to the previous section and take a look at when we were doing that. So this is very generic, right? This is a very generic thing. It's kind of useless in a way because, you know, we're essentially going to call the function on, you know, the args and the quarks. We may as well call it directly, but I just want to illustrate something here. So how do we use that function? Well, we can call apply func, and then we pass in the square function, and we pass in 3, right? So 3 is going to go into args, sq is going to go into fn, and it's going to call sq of 3 and return that value. So we get 9. So it works just as before. But of course, now we can get a little bit more fancy with this. Instead of putting the square function, maybe we're going to do a lambda. Again, we can do it this way, right? So, and 3. So we get the same thing. If I don't def it, I just call apply func, right? So here we go. We created this function x squared, anonymous function that returns the square of the argument, and then we passed in 3 as the argument. Now we can of course get more complicated now because that apply func is very generic. So maybe we do a lambda that takes 2 parameters and returns the sum. So now we need to pass 2 parameters to apply func so that it gets passed to the lambda, and we get that. We get a result of 3. Of course, we can also get even more complicated. Maybe we're going to do something like this. We're going to say lambda is going to take a single positional, no more positionals than a mandatory keyword only argument, and it's going to return also x plus y. So now we have to specify 1 and then y equals 2, right? Or y equals 20, just to keep it different. And as you can see, that works as expected. Y goes into quarks, 1 goes into args, and then we call this lambda, passing it the args, which was 1, and the quarks, which was y equals 20. We can also do this. Apply func. Let's do a lambda that only takes basically positional arguments, arbitrary number of them. And what is it going to do? It's going to return the sum of those arguments, right? So that's the lambda that's going to sum up. And we're going to pass now an arbitrary number of positional arguments to our apply func. Let's say 1, 2, 3, 4, 5. So now we're going to sum that up, and we get 15. Now, of course, you didn't have to do it using a lambda, because remember, what does apply func do? It takes a function and applies it to the parameters that are passed. So we could do this. We could say apply func. We're going to take the function itself, and then 1, 2, 3, 4, 5. Now, that's not going to work because sum doesn't take star args. Sum expects a list or a tuple or something like that. So let's create the tuple, and I need to end that, and we get the same thing, right? Of course, you can also just do this, right? And we get the same thing as well. But again, I just want to show you how you can write your lambdas, right? They can be very powerful expressions, and you can pass in then the arbitrary number of arguments, but that's only because we're calling this apply func that handles an arbitrary number of arguments. All right, so thanks for watching, and I'll see you in the next video.